Okay, so welcome ulit sa ating YouTube channel. Ito na yung lesson 16 ng ating complex analysis. Ito na yung hyperbolic function. Okay, so the hyperbolic sine and cosine of a complex number are defined as they are with a real variable. That is, sine, hyperbolic sine of z is equal to e raised to z minus e raised to negative z over 2. And hyperbolic cosine of z is equal to e raised to z plus e raised to negative z over 2. So ngayon ang gagawin ko, derive na rin natin si hyperbolic secant, hyperbolic cosecant, hyperbolic tangent, saka si hyperbolic cotangent. So unahin ko lang muna si hyperbolic cosecant. Si hyperbolic cosecant, siyempre equivalent sa reciprocal nito. So this is 2 e raised to z minus e raised to negative z. Si hyperbolic secant of z, siyempre equivalent lang sa 2 over e raised to z plus e raised to negative z. Okay, next is si tangent. Si hyperbolic tangent of z is equivalent lang sa, syempre itong part na to, divide lang natin, makakancel lang yung 2. So that is e raised to z minus e raised to negative z all over e raised to z plus e raised to negative z. Then next, the hyperbolic cotangent of z is equal sa e raised to z plus e raised to negative iz all over e raised to z minus e raised to negative iz. Okay, so ayan yung mga hyperbolic function natin. Okay, so let's have example dito sa ating hyperbolic function. So try natin to si hyperbolic sine of 4. So by definition of the function hyperbolic sine of z, this is equivalent sa e raised to 4 minus e raised to negative 4 all over 2. Siyempre, simplify lang natin further yan. This is equivalent is e, which is on e raised to 4 minus 1 over e raised to 4 all over 2. Then multiply natin sa LCD na e raised to 4 lahat ng term. So that is equivalent sa e raised to 8 minus 1 all over 2 e raised to 4. Okay, so therefore ito yung kanyang sagot. Okay, next is let us evaluate hyperbolic tangent of ln of 2. So note that hyperbolic tangent, nasulat ko na kanina na ito ay equivalent sa, yung hyperbolic tangent is e raised to z minus e raised to negative z all over e raised to z plus e raised to negative z. Okay, then input lang natin yung value na z, which is ln of 2. So this is simply equal sa e raised to ln of 2 minus e raised to negative ln of 2 all over e raised to ln of 2 plus e raised to negative ln of 2. Okay, ngayon i-arrange ko lang siya konti. Ang mangyayari, ayusin ko lang muna to. This is equivalent sa e raised to ln of 2 minus 1 over e raised to ln of 2 all over e raised to ln of 2 plus 1 over e raised to ln of 2. Okay, note that yung ln ng ibig sabihin niya is logarithm base e. Tama? So kung meron tayong ganun, ang magiging sagot ng e raised to ln of 2 is just 2. So this is only 2. Kasi nga yung e raised to ln of 2 ay equivalent lang sa 2. Kasi cancel yung ln is logarithm base e. Okay, this is minus 1 over 2 over 2 plus 1 over 2, which is equal sa, ito ay 3 over 2, ito ay 5 over 2, which is equal sa 3 over 5. Ayun yung kanyang value. So sana eksakto yung mag-compute ko, no? 2 minus 1 half is 3 over 2, 2 plus 1 half is 5 over 2. Tama. Then cancel lang natin yung 1 half or divide both side by 1 half, or reciprocal lang natin yan, that is 3 over 2 times 2 over 5. So cancel si 2, so that is 3 over 5 yung sagot. Okay? Then syempre meron din identities dito sa hyperbolic function. So common lang din naman siya kay trigonometric, pero since hyperbolic siya, may iba dito. Okay, so check natin. So, common identities involving hyperbolic functions. So, number 1, hyperbolic sine of negative z is equal to negative hyperbolic sine of z. Number 2, hyperbolic cosine of negative z is equal to hyperbolic cosine of z. Hyperbolic square of hyperbolic cosine z minus square of hyperbolic sine z is equal to what? So, hindi plus, minus talaga yan as in. So, sir, parang yan ba yung Pythagorean theorem dito or Pythagorean identities? Parang ganun, pero hindi natin siya pwede i-claim or sabihin na Pythagorean identity. Okay, hindi siya both Pythagorean. Okay, basta identity siya. Next is yung sum and difference, or yung sum na lang muna. So, hyperbolic sine ng c plus w is sine. So, sin, cos, cosine. So, sinh, cos, cos, sinh. Then, ito yung cosine naman. Yung hyperbolic cosine, that is cos, cos, sinh, sinh. Ayun yung kanyang identity. So, magagamit natin yan later on. So, now, number 6, if z is equal to x plus iy, then sine, or hyperbolic sine of z is equal to, ito yung mangyari, that is equivalent sa hyperbolic sine of x plus iy. Since plus siya, gamitin natin sa taas. So, this is equivalent sa hyperbolic sine of x, hyperbolic cosine of iy, or cosine, sorry, that is, tapos hyperbolic cosine of x, tapos hyperbolic sine of iy. Ngayon, check tayo ng identity about that. Dun sa ating previous na lesson, may identity ba yung cos of iy? Parang baliktad, no? So, ito na yung medyo tricky. So, ano equivalent ng hyperbolic cos of iy? Hyperbolic cos of iy, pag check natin, dito ko nalagay, no? Hyperbolic cos of iy. I-green ko na lang para makita natin. Cos of iy is simply equivalent sa e raised to iy minus plus e raised to negative iy over 2, which is equal sa, ito ay cosine, no? Cosine of y. Okay, next, ito naman try natin si hyperbolic sine of iy. So, hyperbolic sine of iy is equivalent sa e raised to iy minus e raised to negative iy all over 2. So, ito walang identity, I think. Pero, possible to, mag-multiply tayo dito ng i over i, para mangyari dyan, maging I times e raised to iy minus e raised to negative iy over 2i, which is equal sa I sine of y. Okay, nakuha ko. So, therefore, this can be reduced into hyperbolic sine, or sin of x, tapos ito ay cosine lang, so this is cosine y, plus may i yun, so this is plus I cos of x, tapos sine of y. Okay, yan yung kanyang equivalent. Also, sinolve ko na yung isa, or nakalagay na yun dyan, ayoko na isolve, pares din naman yung kakalabasan. Okay, so cos of z, ito yung kanyang equivalent. So, magagamit natin yun sa paghahanap naman ulit ng value ng equation. Kung napansin mo last time sa last video, ginamit ko yung ganito para mahanap yung value ng roots o yung roots na equation natin. Okay, so let's have an example using yung mga identities or yung mga nakuha natin. Okay, so show that hyperbolic sine of z plus pi I is equal to negative hyperbolic sine of z. Okay, so check natin. Paano ba yan? So, start tayo sa left side. To improve. Yung hyperbolic sine of z plus pi I is equivalent ng sa e raised sa z plus pi I or I pi minus e raised sa negative ng z plus pi I all over 2. Okay, then biyakin natin konti yan mga yan. This is equivalent sa e raised to z, e raised to I pi minus e raised to negative z, e raised to negative I pi all over 2. Okay, note that e raised to pi, I pi, or pi I is negative 1. E raised to negative I pi, so ano yung value ng e raised to negative pi, I pi? Ulitin ko lang ha, e raised to I pi is simply negative 1. Si e raised to negative I pi is positive 1. Okay, so pagkakaalala ko. Okay, so therefore, ano magiging value nito? I think negative 1 din. E raised to I pi. Check ko lang This is cosine ng pi o negative pi plus I sine ng negative pi. Okay, ano yung cosine ng negative pi? Cosine ng negative pi, ikot kabila. It is negative 1. Okay. So, ito ay negative 1 din also. Sorry about that. Okay, so this is equal sa negative e raised to z plus na to e raised to negative z all over 2. Kasi negative 1 times negative na to, negative. Negative times negative, that is positive. Okay, then labas ko lang yung negative. So, labas yung negative. Then this is e raised to z minus e raised to negative z all over 2, which is equal sa negative ng sinh of z, which is done. Tama. Okay, next is let us try yung letter B. Siyempre, similar din na mangyayari doon. Gamitin natin yung similar identities na nakuha natin sa taas. So, this is equivalent sa, I think this is improved. So, this is e raised to z plus I pi I plus e raised to negative z minus pi I. Okay, all over 2. Okay, so baka tanong, sir, ba't walang I? Ba't walang I? Ito ay hyperbolic, wala silang I. Okay, then this is equal sa e raised to z, e raised to pi I, plus e raised to negative z, e raised to negative pi I. All over 2. Okay, so check natin. Ano bang value niya mga yan? So, e raised to pi I is negative 1. Tama. Cosine pi. Tama, negative 1. So, this is equal sa negative e raised to z. Then, minus dito, e raised to negative z all over 2. So, I think may mali ako dito na formula. So, i-check ko na lang din yung given. I think ito ay plus or minus. Check ko lang din. Check ko lang Ang nangyari, yung e raised to I pi, ay e raised to pi I, that is negative 1. Tama, kasi that is cosine pi plus I sine pi. Cosine pi is negative 1. Okay, yung e raised to negative pi I, that is negative 1 din, tapos 0. So, pareha silang negative 1. Okay, so ano nangyari? Ito ay equivalent, lalabas yung value na parehas negative. So, parang lalabas na value dito is negative ng e raised to z plus e raised to negative z all over 2. Ito yung pinagtataka sir, which is equal sa negative cos of z. Okay, so I think negative talaga to. Sa book kasi positive lang siya. So siguro talagang typo na rin siguro dun, or di napansin. Okay, then therefore that is done. Kasi yung e raised to pi I is negative 1. E raised to negative pi I, that is also negative 1. Kung titignan mo, kung isasolve mo siya by Euler's formula. Or basta i-try mo, makikita mo yun yung values niya. Pag ginawa mo siya exponential form, or I mean ginawa mo siyang trigonometric form, tapos in-evaluate mo yung value, negative 1 lang siya. So, ngayon din naging tag, just naging negative to, naging negative. Pero ito yung result. So, I guess, mali lang or typo lang talaga si book. Okay, so let us proceed na. Okay, so let us proceed na dito sa ating tawag dito sa ating hyperbolic function. So, useful properties, katulad din kanina yung parang remark na sa other video. So, ito rin, similar siya doon, nagkaroon na ng h or naging hyperbolic lang in terms dito. Kasi nangyari ito. So, yung number 3, if hyperbolic sine of z is equal to 0, that is z is equal to n pi I. Tandaan na, n pi I na siya for n element ng integers. Pag yung hyperbolic cosine of z is equal to 0, that is pi over 2 plus n pi times I for n element of z. So magkaiba siya dun sa previous. Dun kasi walang I na nakalagay. Dito may I na talaga nakalagay. Okay, so let us try ulit na i-apply yan. Ngayon nagdalawang example na ako para at least madagdagan yung idea nyo paano gagawin tong mga ganitong given natin, paano yung mga ganitong solution natin. Okay, so find all roots of the equation such that yung cosine z is equal to negative 2 o yung hyperbolic cosine of z is equal to negative 2. So, similar sa ginawa natin, yung from cosine z, lagyan ko na dito. So, may note ako dyan, gagamitin natin mamaya yan kasi lalabas yan. So, this is yung cosine of z, cos of z is equal to negative 2. So, expand natin to. So, may equivalent tayo nakaraan dyan kanina. So, that is cos x. So, kung naalala nyo, ito ay cos of x plus cos of y o cos of y. Okay. Then, this is plus I sin of x tapos sin of y. Sin of y is equal to negative 2. Tapos, yun ulit, equate natin yung real part sa real part tapos imaginary part sa imaginary part. So, for equation 1, try natin. So, for equation 1, we have cos of x cos of y is equal to negative 2. For equation 2, we have sine of x tapos sine of y is equal to 0. Kasi nga, yung imaginary part dyan is 0. Okay, ngayon, set ulit natin. For y is equal to 0, check natin yung mga values kung saan siya magpipail. Kasi ganun yun eh. For y is equal to 0, that may magpail. Kasi for y is not equal to 0, dun tayo dapat mag-alagay ng sagot. Okay, so check natin. If y is equal to 0, green ko na lang. So, if y is equal to 0, ano yung mga possible na sagot dyan? So, if y is equal to 0, yung cosine y is 1. Tama? Cosine 0 is 1. Okay, so therefore, yung reduce yung equation 1 magiging ganito. So, yung equation 1 magiging cos of x is equal to negative 2. Okay, ngayon, ito yung nakakapagtaka. May value ba ng cos ng negative x? So, ito yung i-check natin. May value ba yung cos ng negative x? Yes, may value siya. Actually, solvable siya eh. Pero, hindi ko ma-imagine. Wait, imagining ko lang din. Okay, so nag-check ako, nag-double check ako. Ito pala, ganito pala siya. Magsiset ka ng value na equal sa 0 kung nasaan si hyperbolic. Kung napansin nyo, doon sa unang example last time, doon sa last video, nag-set ako ng y is equal to 0, tas y is not equal to 0. Kasi, yung involved is si hyperbolic. Ulit niya, ang involved is hyperbolic. So, meaning, in this case, sino yung involved in terms ng hyperbolic? Si x. Okay? So, meaning, ang isaset natin na equal sa 0 ay si x. Tapos, not equal to 0 is si y, ay si x din. Okay? So, ulitin ko dito. Dapat hyperbolic yung isaset natin na 0 or what. Kasi mas solvable naman talaga siya totally. Although, ito, cosine 0 is 1. Kaso, titigil tayo dyan eh. Somewhere titigil tayo dyan. So, ito yung note ha. Kung sa hyperbolic, dun tayo kung nasan yung, kung sino yung nakapaloob sa hyperbolic, yun yung isaset natin na 0. So, ulit natin, if x is 0. Okay, so check natin sino dyan yung magsi-0. If x is 0, ano yung cosine ng x? Yung cosine 0, that is e raised to 0 plus e raised to negative 0 over 2, which is 1. So, mangyari, yung cosine 0, yung cosine x natin, equal sa 1. Yun is sure. So, therefore, yung equation 1, magre-reduce sa ganito. Cosine y is equal to negative 2, which is ito na naman yung nag-fail tayo last time. Sabi ko, si sine is in between negative 1 and 2. Also, si cosine in between negative 1 and 2. So, therefore, walang solution para dito pag x is equal to 0. Ulitin ko lang. Ang nangyari, yung cosine x, when x is equal to 0, that is 1. So, palitan ko ng 1 yun. So, nangyari, that yung equation 1 na reduce sa cosine y is equal to negative 2. Ngayon, walang equation or kahit i-check natin, let's say, arc cosine ng negative 2. Okay, so in-arc cosine ko para makita nyo, math error. So meaning, walang mag-i-exist na y na kung saan equivalent sa negative 2. So therefore, walang solution pag x is equal to 0. So balik tayo dun sa isang case natin whenever x is equal to. So if x is not equal to 0, balik tayo kay equation 2. Okay? Ulit, kung si x is not equal to 0, si sin x, never din magsisiro yan. Okay? So sure ako dyan, si sin x, never magsisiro yan. So ibig sabihin, sa kanilang dalawa, within dito, si sin y, so, sin y, yung equivalent kay 0. Okay, ngayon, since si sin y yung equivalent sa 0, sabi ng una natin property, dun sa unang ginamit natin, ano ba yung property na yun? Ano yung property natin? Yun yung n pi, no? This is if and only if, this implies that y is equal to n pi for n element of integers. Sa sine na hindi ito yung gagamitin natin kasi may age yan. Okay? Next, anong gagawin natin after dyan, sir? Next natin na gagawin dyan, since y is equal to n pi, papalit na natin siya dito sa cosine. Okay, o saan yung y na yan? Ito yung may cosine y. Okay, dyan natin siya ilalagay. Input natin siya kay cosine y. So si cosine y natin ay equivalent kay cosine na n pi. Okay, ngayon, ano na papansin mo kay cosine n pi for n element na integers? Yan, for n is equal to 1, for n is equal to 1, that is pi, cosine pi. Cosine pi is negative 1. For n is equal to 2, that is cosine 360 or cosine 2 pi, isang revolution. Yung cosine is 1. So nagpapalit, it's either 1 or negative 1. So which is this equal to negative 1 raised to n for n element of integers. So kailan siya nagiging odd, kailan siya nagiging 1, kailan siya nagiging negative 1, kailan siya nagiging 1 or kailan siya nagiging negative 1. 1 siya, nagiging 1 siya pag yung n is 1 siya pag yung n even, syempre. Okay? Negative 1 siya pag yung n is odd. So dalawa yung value. Ngayon, ito yung kailangan natin kasi. Ipapalit natin dito yan. Okay? Ito kasi yung iniiwasan natin eh. Kailangan matanggal natin yung negative na yan. So ibig sabihin, para matanggal yung negative na yan, ang kailangan natin, n is odd. Tama? N is odd yung kailangan natin para maging negative yan. So meaning, yung equation 1 na to, anong mangyari? Equation 1 magre-reduce into this. This is cosine of x times negative 1 raised to n for n is odd. Ano mangyari? Para sure ako na yung negative 1 raised to n for n is equal to odd, that is negative 1. So negative cos divided by 2. So magiging mangyari, that is cos of x is equal to positive 2 na lang. So ayun na, dito ko binalik. Yung cosine y, which is negative 1 raised to n, that for n is equal to odd, that is negative 1. Negative 1 divided by negative 2, that's positive 2. Kaya naging positive. Ngayon, dito natin kukunin yung value na x. Paano kunin yung value na x? Arc cosine. So that is x is equal to inverse hyperbolic cosine of 2. Okay? Next is meron tayong value dito. Sorry, tatagos na naman yata tayo sa pababa. Next, meron tayong value na ito, no? So, ayun, no, sinabi ko, yung inverse hyperbolic ng cosine x is ln of x plus square root ng x squared minus 2, which is this is equivalent sa x is equal to ln of 2 plus 2 squared minus 1. So, that is 2 squared minus 1, that is 3. Okay? So, therefore, may value na ako niyan. So, ngayon, meron na akong x, meron na akong y. So, therefore, ano value natin? Ang value natin ng z, o yung roots natin, is equal to ln of 2 plus square root of 3. Okay? Then, etong n pi na to, since ang value natin dyan is gagawin natin, ito nangyari ha. Ang gagawin natin, di ba? N pi tayo dito. Tama? N pi. Kaso, anong ginamit natin na n? Ang ginamit natin na n is add. Naalala nyo? Ang ginamit natin na n is add. So, meaning, ang gagawin ko dito, ilalagay ko dito yung 2 pi i kasi, di ba, ang solution supposed to be ito. Di ba, ito yung value niya. That is n pi. That is n pi. Pero dahil hyperbolic tayo, hyperbolic yung tanong natin dyan, dapat, ang sagot natin dyan is, di ba, Kosh? Dapat ang sagot natin is n pi something. Okay? Kasi, di ba, n pi yan. Saka actually, di ba, n pi yan. Tapos magkakaroon talaga ng i. Di ba? Ito yan magiging plus n pi, tapos ito yung i. for n element of integers. Kaso ito yung nangyari. Ang ginamit lang natin, n is add. So papalitan natin to. I-revise natin to. So this is z is equal to ln of 2 plus square root of 3 plus this is 2n plus 1 tapos pi I for n element of integers. Para sure ako lagi add integer yung ginagamit ko. Okay, so therefore ito yung kanyang value. So I think doon sa isang video, hindi ko sure kung tama ba yung ginamit natin kasi diba nagbago rin tayo dun eh. Actually, kung naalala natin, ginamit natin dun is n is add. Okay, so I think dapat, n is even. No? So I think dapat i-revise natin to. So dapat magkaroon to ng 2 somewhere dito. Okay, so dito ka na sasabihin kasi nga n is even eh. So when n is even, dapat ito ay 2n. Lagyan ko na ng 2. So kayo na magdagdag ng 2 dyan. So gawin ko ng disclaimer na rin dun sa video. Kasi nga even na yung ginamit. So dito napakita ko. At least napakita ko sa inyo yung reason ko bakit pinipili ko siya. Ba't ganito yung ginagawa ng sir. Okay. Next is we have find all the roots of equation hyperbolic sine of z is equal to I. So check natin paano naman to solve yung part na yan. So meron tayo ulit equivalent ni hyperbolic ng sine z. So that is ano equivalent ni hyperbolic ng sine z? Ang equivalent na hyperbolic ng sine z is sine x. Lagay ka lang dito this is sana magkasya. Sin x so sinh. So sinh x cosine y plus I cos of x tapos sine of y which is equal to I. Okay, so ito yung pinagkaiba. Yung real part dito 0. Okay, so tandaan nyo, equate natin yung real part sa real part, imaginary part sa imaginary part. So equation 1, we have sinh of x cos of y is equal to 0. Equation 2, yung cos of x, yung sin of y is equal to 1. Okay, so ngayon, sino yung merong hyperbolic? Siyempre may hyperbolic yung x. Okay, so therefore, yung x is set natin na 0. Okay, so when x is 0, pwede possible kaya na may solution tayo dyan. Check natin ha. If x is 0, check natin. Ano yung cosine? Dito tayo kuha ng value. Ano yung cosine ng x natin? If x is 0, yung cosine 0 is 1. Tama? So yung cosine 0 is 1. So yung equation 2 magre-reduce. Ano magiging sa equation 2? That is sin y is equal to 1. So nakakuha tayong value. Okay na no? That is 1. Yan. Ito yung problema. If sin y is 1, ano ibig sabihin nun? Sir, may value ba na lalabas y sin y is equal to 1? Yes, meron. May value na y na kung saan sin y is equal to 1. Ano yun? That is 90 degrees. Tama? Or something na, I think, hindi lang basta 90 degrees. Marami. Pwedeng 90 degrees plus 360. That is 450 plus another 360 mo yun. Plus, so, yung parang coterminal. So, parang dito mangyari, yung y dito is equal to pi over 2 plus 2n pi. So, for n element of integers. So, ulitin ko lang ha. Yung arc sine of 1, that is 90 degrees. Pero madami yun. Hindi lang basta si 90 degrees. Plus 360 mo, si 450. Plus 360 mo ulit, yung sunod yun. Plus 360. Kasi marami siyang coterminal. So, ibig sabihin, sure ako na may ganyan yan. Ngayon, ano yung magiging value natin? So, kung ito ay 1 na, sure na tayo, may value na tayong y, no? So, palit natin doon. Check natin ha. So, dito, kung siya ay ganon, itong cosine ng pi over 2 plus n pi, dito kasi papalit yan eh. Yung cosine ng pi over 2 plus 2n pi, that is always, ano yung value? I think, cosine pi, that is always 0. Tama no? Sure ako no? Pag yung y is equal to, so yung cosine natin, ito, yung cosine dito sa equation 1, yung cosine ng y natin is always 0. Okay, so, ano naman yung value ng cosine na kung saan si y, sorry. Ito ay magiging ng cosine y is 0. So, mangyari si sin x, si sin x is equal to 0. Yung sin x is not equal to 0. Hindi ko pwede sabihin 0. So, di ba parang magiging ito, no? Times 0 is equal to 0. So, 0 is equal to 0. So, anong nangyari? Wala tayong value na x. I think, wala tayong nakuha ang value na x. Actually, ang value na x is 0. So, sorry. Ito pala, ang value na x is 0. So, therefore, ano yung magiging value natin dito? So, this is z is equal to 0 yung x plus, ito pala yung common ni sir, pi over 2 plus 2 n pi, since wala akong ginamit na iba, for n element of integers. Sorry na dito, ito pala yung x. Okay, so ito yung value niya. If x is equal to 0 pa lang yan. Okay, ngayon, if x is equal to 1, ano naman? If x is not equal to 0, ano naman magiging value na? If x is not equal to 0, so isolate na lang natin. Para hindi maging ano. So ulit ko lang if x equal to 0, lumabas kasi ito. Ito yung value. So, yung sin y is equal to 1, eksakto yan may value to. Tapos, pinalit ko doon, yung sin n pi over 2 plus 2n pi. So, sin 90 degree. So, laging 90 degrees yan. Lagi yan doon. Lagi yan 0. So, sure ako lagi 0. So, cos sin x times 0 is equal to 0. So, laging sure yan. So, ngayon, ito pala yung value ng x, no? X is 0, y is ito. So, nakakuha ko ng value. May value pala tayo dyan. Ngayon, if x is not equal to 0, ano yung mangyari? Punta tayo doon sa equation 1. If x is not equal to 0, si sin x hindi equal sa 0. No, si sin x can never be 0. So therefore, si cosine y is equal to 0. So ayun na naman, babalik na naman tayo doon sa property natin kanina na pag si cosine naman yung ating 0, anong gagawin pag si cosine yung 0? Pag si cosine is 0, that is any value, pi over 2 plus n pi. Okay, so this is if and only if. This implies that y is equal to pi over 2 plus n pi for n element of integers. Okay, next is itong value na to, syempre isasalpak na natin dun sa isa dito, no, sa may sin y. So ano yung sin y natin? So ano magiging result ng sin y natin? Yung sin y, which is equal sa sin ng pi over 2 plus n pi, ito ay sure ako lagi siyang 1 or negative 1. Ganun naman siya. So, yung value na naman niya is negative 1 raised to n for n element ng integers. Okay? Since kailangan lang natin siya yung positive, so ibig sabihin, ang kailangan natin, n is even. So, n is even yung requirement natin dito. Ayun yung kailangan. Para lang lagi siyang mag-equal to 1. So, ano magiging reduce nito? Ang magiging reduce nito is magiging cos na lang. So, that is cos of x is equal to 1. Yan. Anong klaseng value na x yung cos of x is equal to 1? Sir, that is 0. Kung naalala nyo, anong klaseng value na x yung cos of x is equal to 1? Pag cos of 0, that is e raised to 0 plus e raised to negative 0 over 2. Okay, so therefore, ano yung value na x dito? X is simply equal to 1. Okay? Sorry, x equal to 0. Which is, bumalik na naman dun sa solution na isa. In which, ano magiging value natin dito? Ang magiging sagot natin dito is equal to z ulit. Is equal to 0. So, kahit wala tong 0, okay lang. Nilalagay lang ni sir plus pi over 2 plus. Diba, n pi yung gagamitin dapat natin. Pero since even yung gagamitin, gagawin ko na siyang even. So, that is 2 n pi tapos I for n element of integer. So, kahit wala naman 0, okay lang. Nilalagay ko lang para ma-appreciate nyo nasan yung 0. So, kung napansin nyo, in any cases, for x is equal to 0, for x is equal to 0, ito lagi yung solution. So, tama siya. Ngayon, ito yung maaaring maging tanong mo. Sir, what if po nagkaiba ng sagot? Probably may mali sa sagot mo. Kasi, when x is equal to 0, pwede natin i-disregard whenever nagkaroon ng walang solution. So, possible, lalabas lang sa x is not equal to 0 yung solution. Ngayon, pag possible, yung dalawang case, ibig sabihin, dapat equal yung dalawang solution na lalabas mo. Okay, kasi kung na-imagine mo, kung iba lalabas dito, iba lalabas dito, parang ang daming representation. So, hindi mo kayang ilabas sa isang parameters lang or parang sa isang parametric equation lang yung solution mo. Or I think sa multivariable solution mo. Okay, ganun na siya kasimple. Ngayon, next is, hindi ko na tayo didiscuss kung paano na-derive. Aware na kayo dito. Gagamitin lang din ulit natin yung e raised to z plus e raised to negative z over 2, tapos differentiate lang kung paano natin ginawa dun sa unang video. So, hindi ko na siya didiscuss pa kasi alam nyo na yan, derivative lang yan. So, sabi nga yung derivative ng cos of z is sin. Derivative of sin is cos. So, pansin niyo derivative of tang is secant. So, or hyperbolic secant squared of z. Yung cotangent is negative hyperbolic cosecant squared of z. Yung secant is negative. So, tandaan, walang typo dyan. Sure yan. Then, ito ay hyperbolic cosecant of z. Yung derivative niya is negative hyperbolic cosecant of z. Then, hyperbolic cotangent of z. Okay, so hindi ko na ipoprove yan kasi similar din naman sa mangyari. Ang pinagkaiba, wala ditong I. So, hindi mo kailangan ng I, mas madali dito. So, probably dito huhugot din ako ng mga possible na tanong. Okay? So, thank you for watching. Hoping nanonood ka pa dun sa next video natin.